All right, page 310, Chapter 8, Lesson 2, Species in an Ecosystem. There are 2, 4, 6 pages, so 3 the first day, 3 the second day. And of course that last page is the Phase 2 processing, the highlighting and annotating, looking for key details that support the main idea. Okay, on your piece of paper, your name, the date, which is probably March 22nd, 21, class name, AVID 6, Science FNT, Chapter 8, Lesson 2, page 310, all the stuff that comes from there. The name of this lesson, Species in an Ecosystem, in blue. The main idea / essential question. Copy it straight from the book. Read it with me as I'm reading so that you can learn how to pronounce these words and so that you can work on your reading and improve your reading. Every species in an ecosystem has a niche. You can also say niche, which includes the species' relationships with the biotic and abiotic factors in the ecosystem. Okay, so every species, I think we know what a species is, a different type of animal or plant, or like humans are a species. In an ecosystem, we've learned what that is, has a niche. Okay, we're going to learn that a niche is like a special role, what role they play, and we're going to learn details about that. Includes the species' relationships. In other words, how do they all interact with each other? How do they relate to each other? Who eats who? Where do they live? All that kind of stuff. Biotic factors, remember those are the living things. Abiotic factors, remember those are the non-living things. And all of those are in an ecosystem. Okay, carnivore is the first vocabulary word on page 312. So, carnivore. Carnivores are also consumers, but they get their energy from eating other animals that they hunt. So, carnivore, consumers, zoop, hunt other animals. Next up is herbivore, page 312 also. Say all these words with me. Herbivore. This energy is passed to herbivores, which are plant-eating animals. So, herbivore, plant-eating animals. Say them as you're writing them. Herbivore, plant-eating animals. Practice your speaking. Niche or niche, either way is fine. A species' niche is its relationship with the biotic and abiotic factors of the ecosystem. So, niche or niche, relationship with biotic and abiotic factors in ecosystem. Notice the indentations so that you realize that all 3 lines go to that one word. Omnivore, page 312. Again, say it, omnivore. Omnivores obtain energy by eating both plants and other animals. Omnivore, obtain energy eating both plants and animals. Next up, predator. A predator is an animal, such as a lynx, that's this cat right here, that hunts and eats other animals, such as hares. That's this rabbit here. So, predator hunts and eats other animals. And the last one, prey. The animal that is caught and eaten, the hare in this example, is the prey. Prey, caught and eaten. Okay, the first section is niche or niche. When you write it, write the pronunciations. It can be niche or it can be niche. You can say it either way. Read with me. Don't just sit there listening to the video, waiting for me to write something down. Actually read the words so that you practice your reading. Each organism in an ecosystem has its own niche or role in that ecosystem. So a niche is a role. A species' niche is its relationships with the biotic and abiotic factors of the ecosystem. We already have that in our definitions with our vocabulary. It includes where the species lives and how it raises its young. Where lives, zoop, how raises young. Part of an animal's niche is defined by what it eats and what eats it. What eats? A predator is an animal, such as a lynx. Again, there's the example. That hunts and eats other animals, such as hares. There's the hare. The animal that is caught and eaten, the hare, is the prey. Both predators and prey are adapted for their niches. So, predator versus prey is an example of a niche, what they're eating or what is eating them. Adapted for niche. See, they just said that? Adapted for their niches. Adapted for their niches. A lynx can run fast and can easily see and smell prey. Hares also run fast, and their fur usually blends into the background. Some species are generalists, meaning they occupy a broad niche. See the word general and generalists? Like in general, things that apply broadly, it's not specific. So generalist equals broad niche. For example, raccoons are predators that eat almost anything. They dine on nuts, berries, birds, fish, and even garbage. So a generalist that occupies a broad niche, an example is a raccoon. Right? They'll eat almost anything. They'll do anything to survive. Other species are specialists, meaning they occupy a very specific niche. Specialist equals specific niche or niche. For example, evergreen forests, those are the ones that have trees like these, are home to at least 4 species of insect-eating wood warblers. So, warblers. Wait a minute, how can a forest have 4 different species of warblers all eating the same things, eating insects? How could they all survive and find enough food? All the species hunt in the same trees in the forest. Wow, okay. But each warbler species works in a different part of the trees. Hunt different places. 2 species hunt in different parts of the top section of the trees. Another species hunts in parts of the middle section. One species spends most of its time hunting in the bottom section of the trees. So even though they're eating insects and they're all in the same trees, they're in different sections of the tree. The warbler's niches are different in another way. They nest and raise their young at different times. Nest and raise young different times. Because they need more food while they are raising young, nesting at different times means that not all species need more food at the same time. Okay, that makes sense. So if they were all nesting at the same time, they would all need more food at the same time. They'd all be competing with each other, and it would be hard to find food and survive. So they have adapted by nesting and raising their young at different times. The 4 species of warbler can all survive in the same trees because their niches are different. When 2 species occupy the same niche, they compete for the same resources. If same niche equals compete, exclamation point. Because if they're competing, then that means life's going to get difficult. Over time, the more successful species survives, while the other one does not. If you're successful, you will survive. So the arrow comes over here because if they occupy the same niche, they're competing, and then whichever species is more successful is more likely to survive. Okay, look at the example up here. Cape May warbler. Read this with me. This warbler hunts in the top of the tree. It moves vertically along the edges of the branches. Vertically, vertical, up and down. Okay, so it stays on the outside of the tree, and it goes up and down, up here at the top of the tree, looking for insects. Blackburnian warbler. The Blackburnian also hunts in the top of the tree, but it moves horizontally across the entire top of the tree. So it runs in towards the center, and then runs back out to the edge, and it's going back and forth. This one's going up and down on the outsides. This one's going left, right, in and out, back and forth inside the trees. Bay-breasted warbler. This warbler hunts in the middle section of the tree. It prefers the shaded interior. So it's down here, finding all the insects in the middle. Yellow-rumped warbler. This warbler spends most of its time on the bottom part of the tree. So it stays down here, finding insects down here. So they can all survive because they're all finding food in different places or different parts of the tree. That's why they have a very specialized and specific niche or niche. Okay. Let's see. Over here, predator and prey. A lynx is an example of a predator. The hare that a lynx kills and eats is its prey. What is an example of a niche or a niche? An example of a niche is where a creature lives, how it raises its young, and what it eats or what eats it. Examples include predator versus prey situations. Which species is a predator and which species is a prey? Other examples of niches include whether they are a generalist, occupying a broad niche, like a raccoon, where they will eat almost anything, or if they occupy a specific niche, like a specialist, like the warblers who hunt in different parts of the same tree and nest and raise their young at different times of the year. One sentence, we just got like an entire paragraph's worth of information out of our notes. That's what you're supposed to be learning how to do. That's why you're supposed to be reading with me. That's why you're supposed to be thinking and talking with me as I'm making this video. All right, turn the page. Food webs. Okay, let's look at herbivore. A jackrabbit is an herbivore or a plant-eating animal. Carnivore. A hawk is a carnivore or a meat-eating animal. Omnivore. A roadrunner is an omnivore, eating both plants and animals. Okay, see the word herb and herbivore? Herb is a type of plant. That's why they are plant-eating animals. Carnivore. Carne. Well, when you go get tacos, don't you sometimes get carne asada? Or you get carne tacos? Carn is meat. And then omni, O-M-N-I. That means universal or all of or a lot of everything. So an omnivore literally eats everything, plants and animals, either one. All right, food webs. Food webs. You learned that a food web shows the feeding relationships within an ecosystem. Feeding relationships. Both matter and energy are transferred through a food web. Transfer matter and energy. Although each ecosystem has a different food web, all food webs have the same parts. Think about that. Each ecosystem has a different web, meaning different species interacting in different ways. But all food webs have the same parts, like the basic functions. These parts are producers, herbivores, carnivores, omnivores, and decomposers. Producers, herbivores, carnivores, omnivores, decomposers. Don't put the other stuff yet. Just put producers, herbivores, carnivores, omnivores, decomposers. Producers are the plants and algae that produce energy and food using the sun's energy. Oh, that's why we wrote sun's energy with an arrow coming over here to producers. Herbivores eat plants, carnivores eat other animals, omnivores eat all of the above, and decomposers break down dead animals and dead plants to return nutrients. Return nutrients back to the soil where the producers can use it. That's why there's a big arrow with the nutrients. Okay, let's see. Producers are at the bottom of an ecosystem's food web. Producers such as plants and algae use the energy of the sun to make food. That's why we did sun's energy with an arrow. This energy is passed to herbivores, which are plant-eating animals. Herbivores are primary consumers, the first animal in any food chain. First animal in any food chain. Primary. Look at that. Put primary next to herbivores. If herbivores are primary consumers, then that makes the carnivores the secondary, and I put a plus because they might have more levels than that. Remember, a food chain has producers, and then primary consumers, and then secondary consumers, and then they might have a third level consumer. So carnivores are secondary plus level consumers. Herbivores are the primary, the first. Okay, what's up next? Recall that decomposers are organisms that feed on dead plants and animals, breaking them down into nutrients that enrich the soil. Breaking down nutrients, enriching the soil for the producers to use in combination with the sun's energy. Even the desert, with relatively few species, has a complex food web. Guess what? There's a picture of it. Desert food web. Desert producers include hardy plant species such as creosote bush, sagebrush, and cactus. Creosote bush, sagebrush, and cactus. I know that one's the cactus. I don't know which one is the others. Rabbits, mice, and kangaroo rats are herbivores that eat these plants and their seeds. Rattlesnakes and hawks are carnivores that hunt and eat desert herbivores. Okay, so rattlesnakes and hawks are the secondary consumers that are hunting and eating the kangaroo rats, the mice, and the rabbits. Roadrunners are omnivores. They eat whatever is available. Roadrunners eat mostly meat, insects, snakes, lizards, rodents, and even other birds. However, they eat plants in winter when desert animals are scarce. They may also scavenge on dead animals. So we have a desert example on page 313. In healthy ecosystems, populations of each species are relatively stable, meaning they're not fluctuating wildly. You're not getting very few animals or tons and tons of animals very often. The populations are stable. Each population is big enough to reproduce and small enough so that it does not use up all of its food resources. So they have to be big enough to find each other and reproduce and have babies or lay eggs, but they also have to be small enough so they don't eat up all the food that's available, destroy the ecosystem, tear up all the producers, and have nothing left next year. One important role in most ecosystems is the top carnivore, such as the hawk or the lion. These animals indicate that an ecosystem is healthy because they cannot survive without stable numbers of other animal and plant populations. Okay, so if you look at an ecosystem and you're looking for hawks and lions and they're starving, that means there are problems at the levels below. That means that the animals they're eating are scarce or rare. They can't find them. They're having a hard time hunting and eating, which probably means there's a problem with the plants that those animals are eating. Okay, let's look at this desert food web. A food web shows all the feeding relationships in an ecosystem. Find the producers, herbivores, and carnivores shown here. Okay, producers, boom, plants. Notice the arrows are always going away from the producers. That means the plants are producing food and energy. The ground squirrels, mice, and roadrunners are primary consumers, consuming the producers. Okay, herbivores. Well, anything that only eats plants, like a ground squirrel or a mouse, is an herbivore. But, as you can see, the roadrunner also eats meat and snakes. So, nope. Just the mice and the ground squirrel are herbivores in this picture. Carnivores. Okay, let's see. Rattlesnake eats a mouse. Rattlesnake might eat a roadrunner. Rattlesnake might eat a ground squirrel. And that's it. So, rattlesnake is only a carnivore. Rattlesnakes do not eat producers, plants, and algae. Arrows between animals point from prey to predator. Okay, well, if a roadrunner is eating all of the above, they're eating mice and plants and possibly rattlesnakes, then they're an omnivore. And then all the way up here at the top of the food web, at the top of the food chains, plural, because it's overlapping food chains, is the hawk. Hawk is eating ground squirrels, eating mice, eating roadrunners, and even eating rattlesnakes. But it's a carnivore because it is not eating any of the plants. Okay, what are the main parts of every food web? Well, we read this earlier over here. The main parts of every food web, see how I restate the question? The main parts of every food web are producers, like plants and algae, using the sun's energy to create food and energy. Herbivores, which are primary consumers that eat the producers, eating plants only. Carnivores, which are secondary consumers or higher, eating the animals like the herbivores. Omnivores, which eat both plants and animals. And decomposers, which basically get their energy from dead material like plants, dead plants or dead animals, and they return nutrients back into the soil for producers to use once again. Okay, notice in this desert food web, remember they said in the food web there are always producers, boom, herbivores, boom, boom, carnivores, boom, boom, omnivores, boom, and decomposers. Guess what? They didn't show the decomposer here. But my guess is, in the desert, decomposers probably include some insects, maybe some funguses or some bacteria, maybe even some mushrooms. Although I'm not sure you would find mushrooms in the desert. Maybe just some like smaller funguses that don't bloom into a full mushroom. But notice they also said the roadrunner can be a scavenger. So in a way, they're kind of like helping be a decomposer. They're eating all that dead meat. So probably insects, probably bacteria, maybe even some funguses. All right, that's it for day 1. Good job persevering with the growth mindset. Remember to roar, Wildcats.